Hello, everybody. Thank you for being here. I'm very happy to present my work. It's funny because I didn't know, but I'm actually from SUTD, which is the university which was mentioned shortly before by the previous presenter. I work at Singapore University of Technology and Design in the iTrust Center for Research in Cybersecurity, where we focus on cyberphysical systems and security by design. I'm going to present my work on the characterization, simulation, and detection of cyberphysical attacks on water distribution systems. I'm not a security guy, I'm a civil engineer. Let's say I'm on the physical part of cyberphysical system. So this is shortly the contents that I'm going to present. I'm going to give you like a big picture on urban water infrastructure, because I think most people here are not familiar. Then I will talk about cyberphysical security of water distribution systems. And then I will present the test beds, which we mentioned before, that we have at iTrust. And also, I'm going to provide some conclusion. So let's talk about urban water infrastructure. So in this, but anyway, you have the major urban water infrastructure. So we start from water supply. Okay, water supply is from reservoirs. What are reservoirs? Reservoirs basically artificial lakes created when we put like dam in the watershed. So we have this water available, we can draw it, and we can treat it, and we can distribute it to our customers and users, which could be, of course, residential users as well as industrial users. And this water becomes wastewater once it's utilized, and it has to be collected in the sewage and sent to the wastewater treatment plant, which is this one over here. Here, this wastewater is processed, and it can be reused, of course, so put back in the water distribution system, or it can be released into the environment. So, notwithstanding the type of urban water infrastructure that you are considering, actually, these are all cyberphysical systems. Of course, the complexity, the extension, and the topology of the cyber layer depends, in the end, on the type of underlying process they are dealing with. But we are seeing a common trend, which have been already highlighted today, where digital interconnected ICS and SCADA are replacing the analog system that we used to have. And they used to be air-gapped from corporate networks and internet. So this brings a lot of benefits, like higher efficiency, cost savings, real-time capabilities, but unfortunately, we now have a vast attack surface. Indeed, according to ICS CERT, the water sector is the third most targeted sector after manufacturing and energy. So I'm also one of the members of the ASHI Task Committee on Cyberphysical Security of Water Distribution Systems. And along with other colleagues from academia as well as industry, we are trying to come up with a review of major attacks on water utilities. So gathering as much information as we can. We are starting to see from the year 2000, which is the year of the Maruchi Shire attack, which is the most famous one because it was the first one. So before that, nobody could think that water utilities could be attacked by a cyber attack. But actually, it happened back in 2000 in Australia, where a disgruntled employee that was fired from the water treatment plant managed to gain unauthorized access after he was fired, and basically gain access to the SCADA system, activated the pumps, and released untreated wastewater into the environment, causing a lot of damage. So, so far, we have identified 10 major attacks which have been reported and confirmed since the year 2000 on water utilities, on water infrastructures. We're talking about targeted and untargeted attacks which have been affecting very different infrastructures. Who are the adversaries? Actually, anyone, because we have like cases where outsiders have done the attack, or hacktivists, a lot of insiders too, such in the case of the Maruchi Shire attack. There have been, of course, other suspicious incidents that have been reported, but they have not been confirmed, so we won't be considering this in the review that we are carrying out with the task committee. One thing for sure, there are many unreported attacks. So water utilities, most of the times, don't even have the tools or the awareness to know and check if they had a cyber attack in their history. There's a lot of work to do. So we just have 10 cases and 10 case studies so far, but we, from preliminary results of our review, we can say that there are many different goals. We have attacks that are related to terrorism, others are related to revenge, as I said before. They use very different means, sometimes including social engineering and getting insider information. It's nice, it's not really nice actually, but it's important to focus on the vulnerabilities that have been exploited to perpetrate these actions. Indeed, the fact that we have a very poor separation of ICS and SCADA from corporate networks and internet seems to be the major cause for these attacks to happen. This is because there is a lack of awareness at every level, especially at the management level, which is a big problem. And indeed, as a consequence of this, there is a lack of IT and OT specialized security teams. So this was just a big picture on urban water infrastructure, but at SUTD and iTrust, I've been mostly focusing my attention on water distribution system, if you recollect from the first slides that I showed you. So this is a toy water distribution system. You can think of it as a network of pipes in which pressurized water flows. So we have a reservoir, which is the main source of supply, and we pump this water from the reservoir through all the nodes in the network, as well as to storage tanks, which retain some of this water, of course, so they can release later and provide water to the customers. It is a cyber-physical system. So when we put the cyber layer into the picture, we start seeing, of course, sensors, actuators, PLCs, SCADA, smart meters, RTU, and so on and so forth. So, as we said before, this progressive digitalization has brought a lot of good things, but we now have an attack surface, and we got to deal with it. So now, what happens in the water distribution system can be affected by a cyber attack, and we mean, like any kind of problems, environmental, damage to infrastructure, damage to people, and so on and so forth. So at SUTD, with colleagues from other part of the world, we started to look into this problem and gain insight on it. So we needed to start somewhere. So since the field was really new, the field of cyber-physical security water distribution system, we had to come up with an attacker model for water distribution system. So after a lot of thought, we came up with this. So basically, we identified important components as well as location that could be attacked in the water distribution system. And for each of them, we then refined our characterization by considering physical attacks where possible, as well as cyber attacks damaging the security goals of availability, confidentiality, and integrity. So we can, of course, attack on sensors, attack on actuators, attack on the connection links, and so on and so forth. OK, we have an attacker model. So if we want to estimate the impacts of attacks on water distribution systems, at least we have a starting point. But there is no data. Data is a big problem. Attacks are rare. Water utilities are unaware. And most importantly, they are not willing to share information, at least with us from academia. We tried many times. We're still trying. But it's not working right now. Hopefully in the future. But still, we need at least to start to address this problem, right? So when engineers like me don't have data, they resort to computer simulations. So I am the main developer of this tool known as EPS CPA. This toolbox basically allows you to design custom attack scenarios on water distribution system and is open source and is available in my repo here. This toolbox is based on a toolbox which has been developed by EPA, the Environmental Protection Agency of the United States, which is known as EPA Net. Basically, this one is the open source, most important software that one can use in water distribution system analysis. So we took this, we added a cyber layer on top of it, so now we can design attack scenario and simulate the effects of attack scenarios on water distribution system. So these are some preliminary results that we obtained already with the EPS CPA, this toolbox that I developed along with other colleagues, which is described in several papers. I'll show you at the end because you can't see them now if you're interested. Anyway, we can already simulate attack scenarios related to tank overflow, low pressure conditions, unmet demands, as well as total cutoff of supply. So we are still talking just about simulation, but still already we can find some interesting things. For instance, we know that the impact now depends a lot. So the impact, the effect of a cyber attack on the water distribution system depends a lot on the initial condition, the initial state of the physical system before the attack strikes. We can use EPS CPA already on computer models of real water distribution system to assess district vulnerability. So, the water distribution system is divided in districts, and we can see which one is more vulnerable. So if we have to make some investments, to improve security, we can focus on one rather than the other. Indeed, EPS CPA simulations also allow to find windows of opportunity for attack response. So we know actually that from the time the attack starts to the time that we start noticing some damaging effects on our water distribution system, there is some time that we can exploit to respond to this attack, especially if you have in place attack detection algorithm like the one shown in the presentation before. Again, we say that there is no data, so we can use this toolbox actually to generate synthetic data that we can use, for instance, to train or to develop attack detection algorithms. So this is something that we did at SUTD, again with colleagues from Israel and also Cyprus. We organized the first kind of data science competition on water resources. In particular, this is the battle of the attack detection algorithm. So we used EPS CPA, the software that I presented before. We took a computer model of a real water distribution system of a small city, middle-sized city in the Mediterranean. And we generated a lot of data pertaining to normal operation as well as to attack scenarios created using the toolbox on this computer model of the water distribution system. So we gathered all this data, and then we made it public, and we asked people from academia and industry to actually come up, use this data to develop an attack detection algorithm, like the one that we've seen before. These are the results that we obtained. So this competition was actually hosted in one of the biggest, maybe the biggest conference that we have in the field of water distribution systems. So last year in 2017. So you can see that in the end we had 7 teams that managed to go through all the steps of the competition. Most of them were actually able to detect all the attacks in the test data set. To be honest, since it was the first time that we did this, we made it, I wouldn't say simple, but approachable. But of course, the success that they had was kind of varying, both in terms of accuracy as in terms of time to detection, which is another very important metrics. The most important thing of all this study that we put up is that actually there are very different ways in which one could actually build a good attack detection algorithm. If you have a model, you can do process-based approach, which functioned very well in this case, since the winner did that. But artificial neural networks are a very good alternative. Indeed, the presentation before was presenting something that was based on artificial neural networks. Okay, so since we were the one organizing this competition, we couldn't participate. But still, we did some work on generating our own attack detection algorithm, which is based on autoencoders. I don't know if you're familiar with this topic. We're talking about deep learning. I wouldn't go too much into the details here, because I would like to maybe give some time for questions. I don't know. But anyway, so the most important thing about this kind of deep learning architecture is that it's an unsupervised or like a self-supervised of a system without actually having any real data about attacks that happened in the past. So we just train this based on normal operation data, and then automatically this should be able to find anomalies. And this is one of the best benefits that this kind of architecture can give. Anyway, as I want to skip this because we've seen a lot before. Yeah. The learning phase. Oh, well, we train this on GPUs, so it's quite fast, to be honest. Then depends on the case that you have, how much data you have, but it's not really the problem, that one. Now, you cloud computing GPUs, you can do it in, of course, even if you have like thousands of sensors. We did this on 43 sensors. Another good thing about this kind of methodology is that, as mentioned before, but in a different way, in the previous presentation, we can also kind of localize which sensors have been attacked. Okay, before finishing, I want to present the test beds that we have at SUTD. So, as we said before, there is not much data. We can use simulation, but we should be able to do more. So why not having our own miniature water distribution system? Our labs built to resemble real infrastructure, so that you can do a lot of experiments on it. So this is the water distribution testbed that we have at SUTD. It has a SCADA system, PLCs, HMI, storage tanks, demand nodes, pumps, vaults, even stuff to like simulate problems related to water quality. So we have chemical dosing system, analyzer. We also have a leak simulator. So this is a miniature water distribution system. Of course, it's much smaller than the real one, but still, we can do a lot of interesting stuff with it, and we are starting now to really employ it to gain more insight on cyber-physical security of water distribution system. The second one that I want to show you, you already saw it, but you saw a different picture because it was in the previous presentation. This is the most mature testbed that we have at SUTD. It's the Secure Water Treatment, or SWAT testbed. Actually, you saw this picture, actually, but it was bigger. Anyway, this is really like a fully fledged miniature water treatment facility. I think we can work up to 2 cubic meters per hour of water being treated. And it has all the nice processes that you would find in a real system. So we're talking about ultrafiltration, reverse osmosis, UV system, and so on and so forth. And if you have a look at the cyber layer, actually it's very well defined. It really resembles what you will find in a real water treatment plant. And that's why actually people like Kaspersky use this to try their algorithms, actually. Indeed, we have a total of 4 major testbeds at SUTD. Water distribution, water treatment. We also have the power grid, which is the last that we set up. And these 3 actually are interconnected. So we can actually, so the power grid is feeding energy to the water treatment and the water distribution, and the water in the water distribution is being sent partially from the water treatment. So we can also go and study cascading effects of a cyber attacks maybe occurring somewhere else. So we generated data using this testbed, like the one used for Kaspersky and shown in the presentation before. And we also use this testbed continuously to carry out workshops as well as hacking competition with partners from academia and industry, both on the attack and the defense side. So at the same time, we have one team attacking the other and so on and so forth. We've done a lot of work in it, and if you look at the iTrust website, you will find all the information that you want. Of course, you can ask me if you're interested, because now this testbed will be available for actually paid usage by external parties. So if your company, whatever, you want to cooperate with us, you're very welcome to do so. Of course, if it's for academic reason, then I don't think it's going to be a paid usage, but anyway, if you're interested, I can very well put you in contact with some of the project managers at SUTD. Okay, so let's just conclude this talk. Okay, modern water infrastructures are cyber-physical systems. This digitalization has brought a lot of benefits, but we now have a vast attack surface. The water sector, indeed, is the 3rd most targeted critical infrastructure that we have. And major vulnerabilities, as shown in the review that we carried out, and we are carrying out, include the poor separation of ICS SCADA from corporate network and internet. There is lack of awareness at every level of the water utilities, and there is lack of training of specialized personnel that can react to these threats. There are guidelines, actually. The most famous one are the AWA, American Water Works Association, but even in the US, they are not compulsory. They're just voluntary. So if you want, you follow them. Otherwise, you just don't care. Nothing is going to tell you anything about it. And that's a major problem, so I think this is going to change. We see already some efforts in England and other places where actually they want to make their guidelines and then maybe make sure that people actually use them. So finally, we saw the water distribution system are heavily targeted infrastructures. Of the 10 attacks of the review that I introduced, 5 of them, so 50%, are related to water distribution system. It's a very large distributed network, right? So it's maybe it lends more points that can be attacked. Of course, ongoing research is needed to characterize and detect these attacks. There is lack of data. We can compensate it with simulation or with testbed experiments, as we just saw. But of course, in order to have major advancement, we really need like a big collaboration between academia, researchers, as well as industry with the public utilities. So thanks for listening to my presentation. Here's a list of publications that are related to the work that I told you about.